All right, so here we're going to graph a polynomial in factored form. So the first thing we want to do is find your x-intercepts. And so if you notice here in our parentheses that when x equals 3, we'll get a 0, and when x equals -4, we also get a 0. So at 3, we have an x-intercept, and at -4, we also have an x-intercept. The next thing we need to do is identify our y-intercept, and we can do that by substituting a 0 in for our x's. So 0 minus 3 squared times 0 plus 4 gives us a -3 squared times a +4, which gives us 9 times 4, which is 36. So somewhere up here on your y-axis, you need a point at 36. An important thing to note also is that you cannot cross the x or y-axis without going through one of those points. The next thing to identify in graphing this is what is its degree. Okay, so in a factored form, if you look here for the exponents, you see we have a 2, and then where there's not an exponent, we assume it to be a 1. So this means this is a third degree polynomial. The importance of the third degree polynomial is that its in behavior is going to behave like a third degree polynomial. We also need to note that it is a positive third degree polynomial, and we can identify that by looking up here in the front and seeing there's no number. So assuming that it is a +1, it will start down and it will finish up. And this is what we note as the in behavior. And so as we go to sketch a graph of this, we want to figure out what is it doing at 4. Well, when you look at this exponent here of 1, you recognize that it crosses the x-axis. So we come up and we cross at -4. This is a sketch, so we don't really know if we're going to go above 36 or just that 36 is the highest point. The most important thing is that we note that it crosses at 36. Well, to get to 3, we have to come down. And as you come down, you have to look back over here at the exponent on our other root, and you see that it's squared. Anytime you have a even exponent, it's going to bounce. And so it comes down, it bounces at 3, and then it finishes up. And so that is the graph of our third degree polynomial. Our next example, again, we want to identify the zeros. And any time that there is an x out in the front, it doesn't matter about the negative sign, it doesn't matter if there's an exponent. These are all in factored form, and so if there's an x out front, it's always going to be a 0. Which is nice because when we plot the point at 0, 0, it serves as an x-intercept and y-intercept, which means we won't have to find our x-intercept later. Y-intercept. So next, we need to identify our next 0, which is be at -1 and at 2. So at -1, we have an x-intercept or 0, also known as roots. Now we need to determine the in behavior. And so if we look at the exponents on this graph, you see that there's no exponent here on the x, and so that is assumed to be a 1, and there's no exponent on this last factor, and so its exponent would also be 1, making this a 5th degree polynomial. 5th degree. Any odd degree polynomial is going to have an in behavior like a cubic. Now, the important thing to note is that in the very front, this is a negative, there's a negative x, and that negative sign tells us that it's going to behave like a negative cubic, meaning it's going to start up and it's going to finish down. So as we come down to approaching -1, there's also another important thing to mention. any even degree it bounces, any odd degree it crosses. Now, if it's a degree 1, like in the previous example, it's just going to cross normally. But any exponent 3 or higher that's odd, it's going to cross like a cubic. And so as you come down to 1, you need to make sure it has that cubic behavior. And so here it crosses like a cubic. Now I circled that and wrote crosses like a cubic just to note that it is, in case you can't recognize that or in case your artistry is poor. But I really want you to recognize that so that when you see it later on and on given a graph, you recognize that behavior. Now at the rest of these x-intercepts, it's going to cross normally. So when we come back up to go through 0 and come back down through 2, it's going to cross more in a linear fashion. All right, let's move on to our next example. And so again, we have an x out front by itself. And so identifying our zeros, we have x equals 0 and x equals 2. And so we have a 0 at 0 and at positive 2. Again, having an x at 0, it serves as the x and y-intercept. And so our next step is to identify the degree of the polynomial. And again, we see there's no exponent on the x, so we assume it's 1. And then there's a 3. So this is at a 4th degree, meaning that it will have an end behavior like a parabola. And given that the 3 out front is positive, we know that this is going to be like a positive cubic. So it will start up and it will finish up. And so we're going to come down and we cross through 0. And then if you notice on the other factor, it was cubed. So at 2, again, we have to cross like a cubic. And if your arrow doesn't match up to the arrow you drew in the beginning for the end behavior, that's fine. You can just adjust it. It's not a big deal. And so there is our graph. All right, our third graph. And I'm actually going to go back and adjust this problem, or let's just scratch the 0 here on this problem, or the x in the beginning, so that we can practice seeing what the y-intercept looks like again. Listing our zeros here, we have x equals 2, x equals 1, and let's make this a positive, or x plus 1, so we have x equals negative 1. And so we don't have an x at 0. See guys, if you make a mistake, you can just erase it. It's not a big deal. So at 2, we have a 0. At 1, we have a 0. And at negative 1, we have another 0. So y-intercept. So the y-intercept, we're going to plug a 0 in. So we have negative 2 times 0 minus 2 times 0 minus 1 and 0 plus 1. And so this gives us negative 2 times negative 2 times negative 1 times a positive 1, giving us 4 times negative 1. And so we're going to get a negative 4. And so down here on the y-axis at negative 4, we need our y-intercept. Again, we need to determine the degree of the polynomial. And so since there are no exponents on these factors, we assume they're all 1s. So this is a 3rd degree polynomial. And because of the negative 2 out front, we know that it's going to be a negative 3rd degree polynomial. So it's in behavior. It will start up and it will finish down. And so coming down to 1. And also just to note real quickly that all the x-intercept, or all the degrees are 1. So it's going to cross normally through all of these. Just make sure that You hit your y-intercept, come up, come back down, and there's our graph. Let's put one more in here. So let's give the equation y equals x minus 2 squared times x plus 3 squared times x minus 4 times x plus 1. Okay, so again, I need a little more space. And so first step in always doing this is identifying your x-intercepts. And so we have a 0 at 2, a 0 at -3, a 0 at 4, and a 0 at -1. And so 2, -3, 4, and -1, we have zeros. And then our y-intercept. And so plug a 0 in for all your x's. And so if we multiply this or simplify this, we have -2 squared times 3 squared times -4 times 1. And so this will give us 4 times 9 times a -4 times 1. And so this gives us 36 times 4, or -4, which would be 148. Sorry, 144. And a -144. So we go down here to -144. And we need to identify the end behavior of this. And so if we look at the degrees on each of the factors, again, no degree, so, or no exponent, so it's to degree 1. And if we 2 plus 2 plus 1 and 1 is 6. So this is 6th degree. So because it's even, it's going to have an end behavior like a parabola. And given that there are no numbers out front, we assume that it is a 1. And so it is a positive parabola. So the end behavior is going to start up and going to finish up. Now pay attention because 2 of these factors had squares on them, so it's going to bounce twice. So just make sure that when you're graphing it, you're paying attention to where it bounces and where it doesn't. So I know it's going to bounce at -3. So when I come down to -3, I need to bounce. Again, we don't know how high it's going to go up, but this is just a sketch. I know that it's going to go down through 1 or -1. It can't cross the y unless it goes through the y-intercept. At 2, it's also going to bounce, and then at 4, it's going to cross. And so there is our 6th degree polynomial with 4 roots. I hope these examples helped.